Alrighty, welcome once again to the JBoss booth. Today we're going to be talking about JBoss in the cloud using our JBoss Cloud project. First of all, I'd like to point out Mark Goldman over here. He's the guy who's kind of behind it all these days. And so let's jump right into this. So before we start talking about the cloud, we need to define what the cloud is to us. To us at Red Hat, we believe the cloud to be OS level virtualization. So we're not talking about grids like the Google App Engine or SunGrid Engine or anything like that. We're talking about actually having at least virtual hardware that you're installing an operating system on and building up from there. So one of our goals for this project is actually to have kind of a pre-packaged best practices built right into this portfolio of images. And we want to support both internal and external clouds. Why are we even bothering with this? Mostly because virtualization makes clustering really easy and convenient. And when clustering is easy and convenient, then scaling becomes easier and convenient. Also, Red Hat, being an operating systems company, has a lot of good tools for creating these images. We build up from Fedora or from RHEL itself. And this will ultimately lead to kind of push-button deployment of your app from development to getting it out there in production at a large scale. So some considerations when you're working in the cloud as opposed to working on bare metal within a data center is that most environments will have multicast disabled. And when you don't have multicast, it's going to really affect cluster formation. The nodes aren't going to be able to find themselves. Normally they use multicast to announce themselves and find each other and to form up into a cohesive cluster. Also, most cloud environments, you're not assigning static IP addresses to your machines, you're booting from DHCP. And so it's even hard for a human to go in there and say, all right, you guys are all a cluster, because you got to go discover which addresses are bound to each machine. And then since you want to be able to build up a cluster and add machines quickly, you want to make sure they're homogeneous and not involving too much or any manual configuration if you can help it. Because you really don't want to be logging into 200 machines or 15 machines or whatever you're doing to execute commands and change configuration. You just want it to work. So we have some workarounds for this. This is what I'm calling the best practices. We have taken the common JBoss stuff and we've made the configuration changes you need to run in this cloud environment. So like to overcome the lack of multicast, we use the JGroups gossip router. And that becomes kind of a single well-known point of rendezvous that all the cluster nodes can attach to and learn about each other at. Thankfully, most of the cloud environments do allow direct communication between the nodes themselves. So the gossip router is really only used for discovery. We're not using it to route all traffic through it. And then we use a tool called Puppet, which is Ruby-based, but we use that to kind of handle the configuration of once a machine comes up, it booted off DHCP, we need to set the bind address for that instance. And Puppet lets us kind of inspect the machine, figure out what IP address it has, and then go jam that into our JBoss configuration without a human doing any SSHing. So really the main deliverables from this project are what we're calling appliances. An appliance is just a full server image of whatever it is you need that works on a single kind of a single point of what you need to do. You might have a front-end appliance, you may have a search appliance, like Google has a search appliance. You may have a JGroups appliance, like that runs this gossip router I just spoke about. You may have a front-end appliance that's running Apache in your load balancer. You may have a database appliance. And when I say appliance, don't think hardware. We can certainly put it on hardware, but it's actually just kind of the ISO image or the disk image that you can blow onto raw hardware or stick it into a virtualized machine. And so when we boot up JBoss Cloud, what we're looking at here is kind of a handful of different types of nodes. We have our front-end appliance, which does have Apache. It has the load balancer. We're using a JBoss Mod Cluster 1.0. We have our back-end appliance, which is basically your JBoss AS nodes, your compute nodes. And then we've also just put together a PostGIS appliance as just a database that's available to you. But if your app doesn't need a database, you don't have to use that appliance. And then we also have what's called the management appliance, which currently is a little bit of handwritten code, but we're going to be moving that over to John or Jopper to actually manage the communication and the monitoring of all these different nodes. Even though we've kind of pre-constructed this portfolio of a handful of different appliances, we certainly may not have accommodated your use cases or how you want to run it. So we actually, the JBoss Cloud project is not just the appliances we've created, but also the tooling to expand on those appliances to create your own appliances. And so you can use that tooling if you want to create your own. So now we're going to do a demo. This is what, in this demo, we're going to be launching a cluster on EC2. So this is going to start running here. Since we are on EC2, we have these AMIs that are registered, and if you go to our Odd Thesis site, we've enumerated all the AMIs that you can go today and boot up if you want. So we start by grabbing the AMI for a management appliance, and we just copy that, and we can head back over to our AWS management console and just go searching for the AMI, because that list is kind of long. So we have found our management appliance. We select that sucker, we hit launch, and when you launch an instance on EC2, Amazon puts up this extra little form you got to fill out where you tell it the number of instances. We only need one management appliance. This is ours that goes out and discovers everything. We're running the 32-bit appliances here, but you could certainly run the 64-bit version if you really wanted to. And then we pick our SSH key pair. We have a public-private key pair that Amazon makes us keep up with, and we've just selected that. And since our management appliance has to be able to go discover all the other nodes that are out there, we actually have to paste in our Amazon credentials in a base64 encoded form. This is just so the management appliance can run things on our behalf to describe the instances that are out there, see which other nodes it needs to kind of attach to and figure out and weave together. So we click launch, and Amazon's going to go churn for a little bit. So that's our management appliance. That's kind of the core that just kind of keeps everything together. So now we need some front-end appliances. This will be your Apache and your mod cluster. So we copy that AMI, and we go find it once again in the console. And just like the other one, we select it and we launch it. And here we're just going to launch one. Once again, we're going to make it on the small compute type. We select our key pair again. On this one, though, it doesn't have to do anything on our behalf. It just needs to start up. So we don't have to give it our credentials or anything when we boot it up. So we just click launch, and it's off and going. So at this point, we have our management appliance, which kind of coordinates everything, and we have a front-end appliance. But that's not a cluster yet. So we now need to grab our back-end appliance, and this will be the appliance or the nodes that actually are running JBoss AS5. And so just like every other time, we paste in the AMI, we select it, we click launch. But a cluster of one isn't interesting, so we're going to do two this time. And we launch up two of these instances. We select our key again. We hit the big go button. And now time is going to pass. If you're doing this in real life, it may take a few minutes while Amazon thinks about what's going on. But here, magically, through video, we've actually seen that we have four things running. The top two are going to be our management appliance and our front end. And if you notice the last two running ones, they have the same AMI. Those are our back end appliances. So these are booting up. They're finding each other. And so now we have a cluster. We haven't seen it yet, but let's take a really simple application. We have a nodeinfo.war file. All it is exactly one page that gives you information as to what the IP address of the AS you're looking at is. So we're going to use SCP to copy that over to exactly one of our back-end nodes. We're using the farming service that AS5.1 now supports, so we only have to put the WAR file on one of our cluster nodes, and it will magically find its way to the other cluster nodes without any other intervention from us. So right now, we're going to go take a look at the mod cluster management screen. This is where we can see what the front end thinks the back end looks like. And here we see that the front end has found two back end nodes, and each of the back end nodes has the node info application deployed. We haven't had to tell them about each other, they found each other by themselves. So now we go to our front end URL, but we access the node info, and if we hit reload and we've turned off cookies so we don't have session affinity, you see that each time we're hitting a different back end node. Our front end has found all the back ends, it's directing requests to each one. And if you had cookies enabled, you'd have session affinity and you'd hit exactly one back end node repeatedly. All right.